Spherical lens. A spherical lens is a transparent material bounded by two surfaces, one or both of which are spherical. A piece of transparent medium bounded by at least one spherical surface is called as a spherical lens. Lenses are of two types. First one convex and the second is concave. First, convex lens. A lens having both spherical surface or one spherical surface and the other plane surface such that it is thick in the middle and thin at the edge is known as convex lens. They are of three types. First, biconvex or double convex lens. Second, plano-convex lens and concavo-convex lens. And the ray of light parallel to the principal axis after refraction through a convex lens meet at a point on the principal axis, so it is called as a converging lens. Second one, concave lens. A lens which is thicker at the edge and thin at the center, that is curved inward, is known as concave lens. It is also of three types. First one, double concave lens, second plano concave lens, and the last convexo concave lens. Next, a ray of light parallel to the principal axis after refraction get diverged and appear to come from a point on the principal axis on the same side of the lens. So concave lens is called as diverging lens. Refraction by spherical lens, or we call as rules for image formation in lenses using ray diagram. We already studied that the different rules followed for that convex concave mirror. Now we study about that some lenses. What are the rules we following? Here mainly three rules. First one, in a convex lens, a ray of light parallel to the principal axis after refraction passes through the focus on the other side of the lens. In a concave lens, it appears to diverge from the focus on the same side of the lens. Second rule, in a convex lens, a ray of light passing through the focus after refraction goes parallel to the principal axis, while in a concave lens, a ray of light directed towards the focus after refraction goes parallel to the principal axis. Next, the third one and the last rule, in a convex lens and a concave lens, a ray of light passing through the optical center goes without any deviation. Image formation by a convex lens. From lens formula, we find that for a lens of a fixed focal length, as object distance changes, the image distance also changes. Moreover, when the object distance decreases, the image also increases. This changes the position, the nature, and the size of the image. The first one is that when the object is at infinity, the image is formed at the focus and it is highly diminished, real, and inverted. Second one, when the object is beyond 2f1, the image is formed between f2 and 2f2 and it is diminished, real, and inverted. Third one, when the object is at 2f1, the image is formed at 2f2. It is the same size as the object, real and inverted. Fourth, when the object is between 2f1 and f1, the image is formed beyond 2f2 and it is enlarged, real, and inverted. Fifth, when the object is at f1, the image is formed at infinity. It is highly enlarged, real, and inverted. Sixth and the last one, when the object is between f1 and O, the image is formed on the same side of the lens. It is enlarged, virtual, and erect. Image formation by a concave lens. First one, when the object is at infinity, the image is formed at the focus f1 on the same side of the lens and it is highly diminished, virtual, and erect. Next, the second and the last one, when the object is between infinity and f1, The image is formed between f1 and O on the same side of the lens, and it is diminished, virtual and erect. Sign convention for spherical lens. It is a convention which fixes the sign of different distance measure. The sign convention to be formed in the new Cartesian sign convention, and it has the following rule, same as that mirror. The first one, that the principal axis of the lens is taken along x-axis of the rectangular coordinate system, and the optical center of the lens is taken as origin. Second, all distance are measured from the optical center of the lens, and the distance measured in the same direction as the direction of incident light are taken as positive, and the distance measured in the direction opposite to the direction of incident light are taken as negative. Next, distance measured upward and perpendicular to the principal axis are taken as positive. Same way, the distance measured downward and perpendicular to the principal axis are taken as negative. The focal length of a convex lens is always positive, that of a concave lens is always negative. That means the sign convention for the spherical lens is the same as the spherical mirror, except that the distance are measured from the optical center. That is, the focal length of a convex lens is positive and the focal length of a concave lens is negative. Lens formula for spherical lenses. The lens formula for spherical lenses is the relation between the object distance, the image distance and the focal length, and the lens formula is expressed by 1 upon V minus 1 upon U is equal to 1 upon F. This formula is valid in all situations for any spherical lens. Take a proper care of sign of different quantities while putting numericals value for solving problems related to lens. Next one, magnification produced by spherical lens. The magnification for spherical lens is the ratio of the height of the image to the height of the object, and the magnification which is equal to height of the image upon the height of the object, which is denoted by m, is equal to hi upon ho. The magnification is also related to the object distance and the image distance, and it can be expressed as magnification m is equal to hi upon ho, which is equal to v upon u. It is same as that means for that mirror, but only the sign will be different. Power of lens. It is the capacity or the ability of a lens to deviate the path of rays passing through it. A lens producing more convergence or more divergence is said to have more power, and it is represented by a symbol capital P, and the power of lens depend on its focal length. So power is equal to 1 upon F in meter. The SI unit for the power is diopter, that is represented by capital D, and 1 diopter is the power of the lens whose focal length is 1 meter, and the power of the convex lens is positive and the power of a concave lens is negative.